When the liquid is flowing, we study two things. One is viscosity and one is the flow. First thing, when the liquid is flowing, we see the nature of the liquid which is flowing. Sometimes it is very peaceful, silent, and yes, what is that? Streamline. In the streamline, what happens? The particles which are flowing, A, B, C, D, after some times we see them. They are A, B, C, D. Same serial is there. But there may be another type in which once we see them A, B, C, D, and here we see them again, these four particles, and what we find here, A, C, D, B. What has happened? This B has jumped over it and it has come here. This jump, he has to go by the side. So he has developed a pressure on the sides, went to side, go like this, and then again enter. This has done like this. This flow is known as turbulent, and this is known as streamline. Right? So when the Q is maintained and no overtaking, then it is streamline, and when there is a overtaking, then that is turbulent. In the turbulent, what is the effect? Effect is this is a pipe. It is a pipe. All are moving in the straight line. No pressure on the borders. No pressure on the surface of the pipe. But in other case, in the case of turbulent flow, what will happen? This is the pipe. It will press the pipe. It will press the pipe. So the pipe is pressed. The surface is pressed, and after some time we find the pipe cracks. You have seen the cracked pipe just by the side of the road or anywhere. Why it is there? Because the flow might have gone turbulent. That is the reason. So in the turbulent we find that there is a pressure on the walls of the pipe and the walls will break. There is a pressure on the walls of the river or canal, what it is, and that will also break. So the flow has to be streamlined. It should be. So this is streamlined and turbulent, and the velocity after which it becomes turbulent. Why it becomes turbulent? Velocity is more. What is the velocity called when it changes to this? Pardon, anybody? When a streamline velocity converts to turbulent flow, streamline to turbulent, after a fixed velocity, that is known as critical velocity. What is that?
Critical velocity.
Okay. Now in a we are studying streamline flow because there are no rules for the turbulent flow, what we are going to study. In a streamline flow, there is a law known as continuity. This says that if there is a pipe and a very long pipe, at this cross section we see the water flowing is 5 liters per second. Here what we see coming out is 5 liters per second. It has to be same. Why it has to be same? Because there is no storage inside. Once it is filled up, after that if 5 liters enter from this side, there is no storage. 5 liters has to go from that side. That is why we find same. That means every 1 second, how much water is crossing this? 5 liters. This 5 liters. Now if area is same, then the length crossing per second is also same. And length crossing per second is what? Velocity, speed. That means the speed at every point is, at every section here, the speed is same. Speed is same. Actually, what is same in these two? The volume. What is same? Yeah. So at every section, the volume flowing is same. There are so many streamline flow are there, but here area is large, here area is small, here the velocity is V1 and here velocity is V2. What is same thing in this answer? The volume flowing is same. Volume per second is same. And what is volume? Area multiplied by length is same. Area into length per second is same. Now length per second is what? Velocity. So area into velocity at different cross section is same. Here area is A1, velocity is V1. So this is A1, V1. Here area is A2, velocity is 2, A2, V2, and it may be A3, V3, A4, V4. All this is what? Same. So the volume continued to remain same at all the cross section. This is principle of continuity. Principle of? Yes. Principle of continuity. Volume per second is same. That gives A1 V1 is equal to A2 V2. A3 V3. Any section. Please remember this. And what does this is shown? A into V is volume per second. Volume per second. The volume converts into area multiplied by length, and length per second is velocity. So area into velocity at every section is same. Right? So this principle you will remember, and this we are going to use at many places. Okay. Now, when the liquid is flowing, we will study viscosity later. Let's come to Bernoulli's equation first. When the liquid is flowing, according to law of conservation of energy. Conservation of energy we can apply anywhere. A liquid flows because there is a force acting on it. Force means there is the effect of the force. That means liquid is under certain pressure. When we want to flow liquid, we apply a pump, and the pump compresses the fluid. That creates a pressure. Okay. So there is a pressure plus all the molecules of the fluid have got velocity. There is velocity, and those fluids may be at certain height from the ground. So all these fluids have got three type of energy with them. Three type of energy. So we start from here. That is what Bernoulli told us. Okay, the liquid is flowing this way, like this. This is a small area, this is a large area. This is a height h1, this is a height h2. Here it has certain velocity v1, we find here it is going with velocity v2. Here there is a pump pressure P1, here we find the pressure has become very less, P2. So see these two cross sections, but only one condition is there, that this is a streamline flow. This is one stream, this is other stream, this is third stream, this is fourth stream, so this is a streamline flow. In streamline flow, what happens? A1 V1 is equal to A2 V2, there is a continuity and there is no overflow. Right. So, the particles here have three types of energy. One is energy due to pressure. Due to energy, pressure and energy. Do you remember any formula of pressure into energy? P into V. P into V is what? That is work done. We have done it many times in the gas equations. PV is work done by the gas, by the fluid. So here, the volume which is moving is V. I will write it capital V this way because there will be a velocity also coming over here. So pressure into velocity, that gives the work done or the energy here. Then we have height. Due to height, which energy is there? Potential energy, FGH, and due to velocity, with energy is there? Half mv square. So these are the energies contained by every particle of the fluid which is in motion. How much is the total energy? This. Right? Now, energy per unit volume. Divide all with the volume. Energy per unit volume. When we divide it with volume, what we get here? P. Divide it with volume, mass by volume, rho. Divide it with volume. Now this is expression for what? Energy per unit volume. So, yeah, Bernoulli said that this energy per unit volume remains same throughout the motion. That's true, right? That is Bernoulli's principle. That means at this location, what was this energy? P1 plus, this is H1 rho G plus half rho V1 square is equal to P2 plus H2 rho G plus half rho V2 square. This is Bernoulli's equation. This can be written into many forms, but this is a fundamental equation you must remember. If we say the work is done by pump, how much work is done? P1 minus P2, bring P2 here. P1 minus P2. And all this work will be on the other side. Right, so this is Bernoulli's principle. Now, based on this Bernoulli's principle, we can do many calculations. Like, suppose we are considering a flow which is at the same horizontal level. Same horizontal level. This is what? Okay, so there will be one question. Bernoulli's principle based on which basic principle? Bernoulli's equation based on which basic law? Law of conservation of energy. Remember it. Okay? Because energy at every point is same. Now, in a horizontal flow, if there is a flow in a pipe and the pipe is horizontal, or that thing, that space where there is a flow, this is horizontal, so 2 points will be at the same height. If the 2 points are at the same height, then this formula will reduce. H rho G will be cancelled out. So what do we have? P1 minus P2 is equal to, okay, and this we transfer on that side, is equal to half rho V2 square minus V1 square. This is a very versatile formula on which we keep working. The difference of the pressure is created by change in velocity. This is very important. So, change in velocity create difference in pressure. This is an important principle which application is done, and this is a matter of examination value. And with this principle, the aeroplane flies. How do the aeroplane fly? You have all seen that the side view of the aeroplane wing is like this. And this is the side view. That means this is the aeroplane going. This is the wing of the aeroplane. This way it is going. And this is what I am showing you. This part. That is this way. So this is a wing like this. Now, when the aeroplane moves in this direction, it cuts the air, or we can say the air is going across it. What is the direction of air? This. And this air has to go by this. This air has to go by this. So this is 1, 2, 3, 4, 5. These are 5 streamlines. Now see here. This is going from this place to this place, and the time taken for the full streamline going from this place to this place, the time taken is t. Okay? Because the whole atmosphere, the aeroplane goes like this. So what happens? All these particles, they go through this larger path. This path is L1. This path is L2, which is larger than L1. Both are taking time t. How it is possible? It is possible if the velocity of these particles is more. So they are moving with a velocity v2. These are moving with a velocity v1. Now, with v1, they have to cross only L1. With v2, they have to cross L2, which is faster. V2 is faster. So V2 is more than V1. V2 is more than V1 in a streamline. But whenever V2 and V1 are different, then what is created? Here the pressure is P1 and here the pressure is P2. Can you tell me which is larger? We have studied what? P1 V1 is equal, no, P1 V1 is equal, no, this one. V2 is larger and V1 is smaller. This is a positive quantity, so, or leave that. Before we transferred it, what was our equation? P1 plus half rho V1 square is equal to P2 plus half rho. Now if we increase V1, this will decrease. If we decrease V1, pressure will? Yes. So P plus half rho V square is equal to constant. This you understand? 1, 1, 2, 2, 3, 3, all will be same. So this is a constant. In a constant, if we are increasing velocity, the pressure will decrease. If we are decreasing velocity, the pressure will increase. So here we are increasing velocity, the pressure will decrease. So V2 is larger than V1, therefore P2 is smaller than P1. Understand? Because their sum has to be constant. Now, P2 is smaller, P1 is larger. How does it affect? You see, P2 is pressing this surface downward, this way. P1 is pressing this surface upward. Which is larger? P1 is larger. P2 is smaller. So there is a ultimate pressure. How much? P1 minus P2. This is the resultant pressure. In which direction? Which is larger? P1 is larger. So there is a pressure upward. And this pressure converts into force. By which formula? Pressure to force? Pressure multiplied by area. So all the area of the wings, everywhere there is a pressure upward, and that makes a force upward, which we call upthrust. That is the force acting upward. And this force is so large, how can we enlarge this force? The answer is P1 minus P2 is V2 minus V1. When we increase the velocity, the pressure difference increases, the force increases. That's why aeroplane with a smaller speed cannot be lifted. What it needs? High velocity, then only it is lifted. Understand? Then their wings have to have a large area so that force is large. So this is how it is lifted. We will also have to solve numericals based on this equation. Please remember this. Right? If you go to higher classes, engineering classes, even H will be included in it. But at present only pressure and velocity. This is the pressure difference. So this is Bernoulli's theorem. As the effect of Bernoulli's theorem, this is one effect. There are dozen of effects we study. Like in the huts where there are roofs and the air is flowing, the room is locked. If the room is locked and there is a rooftop over it, then this room is locked and this is the rooftop. If the air is flowing this way, then because it is locked, there is no air below it, but the air is flowing on top of it. So here the velocity is 0 and here the velocity is very large. There is a difference in velocity, and difference in velocity will create pressure difference. Where the velocity is more, the pressure will be less. So here P2 will be less and here P1 is normal because velocity here is 0. So this pressure is pressing it this way and this pressure is pressing it this way. When there was no flow, both the pressures were equal. From down inside the room and from outside the atmosphere, both the pressure were same. So the roof was there. Now what happens with the flow? The velocity has increased, so the pressure has decreased. So this pressure has decreased. This has increased. What will happen? There is a force upward, so the roof will fly off. So we wonder, the room is closed. There was no air inside. Flow of air was not there. But even then, it has flown off. Why it has flown off? The upside pressure has become less. So, resultant was up. That's why it has gone up. Understand? Similar, there are so many examples. If we are standing close to the train, there is always a possibility of accident. We can be sucked towards the train. Why? Because if the train is coming here, the air here will start moving. The velocity become large, the pressure will become less. And here the pressure is same. So here is high pressure, here is low pressure. The person is pushed towards the train. Later he looks who was pushing me. But the most important thing, what is asked, especially from medical students, is the blood pressure. When we are running, walking, our blood pressure will increase or decrease? Okay, we find it decreases. Why? Because the blood starts running. And anything which is running higher velocity, what will happen to its pressure? Yes. So, when somebody is walking, the blood is running, the pressure become low. I am a patient of blood pressure, I realize it. It happens. Most of the cases with the hyper blood pressure happens in the night, 3 o'clock. Why? Velocity of the blood is lowest. The blood pressure become highest. Understand? But whenever blood pressure is high, what do the doctors say? Lie down. Yes? Because there is a limit. If the pressure is very high, the flow has become turbulent, then what we want? It should become streamlined. So what is method for that? Lie down. Take some rest. So that extra blood supply, which is making it turbulent, that is terminated by the heart. And it comes to regular blood supply. Remember? So there are so many things you will study in medical. But very basic thing is that if the blood is running, its pressure always comes down. Up to which level? When the flow remains streamlined. It should not exceed that. And that is what happened when it exceeds, when we start running. And when we start very fast running. So if an old man runs very fast, so how the flow will be? Turbulent. And there is always a risk of that wall getting punctured. Blood vessels getting punctured. So it is all related to all the principles. Understand? So this was Bernoulli's theorem. Now we go to the next thing, that is viscosity. Viscosity. Viscosity is again property of a fluid. This is comparable with friction. What does friction do? It opposes the motion, relative motion. Similarly, viscosity also opposes relative motion. This relative motion may be fluid to fluid and this may be solid to fluid. Like if there is a flow in a canal or in a pipe, there is one layer which is very close to the surface. There is one layer which is at the center, like this. What we find, the layer at the center has got large speed. The next layer has got less. This layer has got less speed. This has got less speed. And this last one has got least speed. And the one along the surface is almost zero, because of the hold of the surface. So the velocity goes on decreasing here and here. This is why it happens. because there is a friction between the different layers of the liquid, and that quality, that property of the liquid, that it creates opposition to velocity within the different layers when they are sliding one above the other. That property is known as viscosity. So viscosity is the property which opposes the motion of layers between the fluid, right? That is viscosity. Okay, how do we calculate it? The force of viscosity per unit area is proportionate to this velocity gradient. That means if the velocity is decreasing here at the rate of delta V, please listen it. Here the velocity was 10, here the velocity is 8, here it is 6. 10 to 6, how much is the change in velocity? 4. That is delta V. Divided by this distance, it has decreased 4 by a distance of 8 centimeter. This 8 centimeter I write L. So in 8 centimeter, how much it has decreased? 4 velocity. In 1 centimeter, how much it will decrease? 4 by 8. Every 1 centimeter, it is decreasing half, 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 half. This is known as velocity gradient. What is this? Delta V upon L. This is velocity gradient. Now it is decreasing. Why? Because there is a force between the layers. And what do we call that force? Viscous force, viscosity force. So that force per unit area, that force, this is layer, this is another layer. See here, unit area. The force is acting, the force acting per unit area is known as this quantity, force upon area. This force upon area, if it is more, the velocity gradient will be more. Right? Gradient means what? Difference. There will be large difference in velocity. This will be 100, this will be 10 if the force is more. So force is proportionate to what? Change in velocity per unit length. Now in this we make equal. F upon A is equal to a constant delta V upon L. This constant is now equal to F upon A divided by delta V upon L. This is coefficient of viscosity because the force depends upon this. So coefficient of, if delta V upon L is equal to 1, then eta is equal to what? Force per unit area. What is delta V upon L? Okay, listen. In a fluid, if velocity gradient is 1, in a fluid, if velocity gradient is 1, then the force acting between layers per unit area is its coefficient of viscosity. The resistive force is viscosity. Understand? This is the definition of viscosity. I doubt very much definition is not asked, but maybe with reference to all this, some question may be formed. Like, what is the unit of velocity gradient? Pardon? What? Unit. Per second. Okay. This is meter per second and this is meter. So it remains per second. Very good. And similarly, if we go for dimension, that is t to the power minus 1. Right. Now for viscosity, this is per second and you can find out from here. Okay. So it comes to be a very complicated unit. So we have given it a new name. What is that new name? Poise. What is that? Poise. And because the poise is a smaller unit, we make it decapoise. Deca is larger? Yes. Okay. So Poiseuille was the scientist, so the unit is poise. This is property of viscosity. Anyway, definition, unit, dimensions are not very important. What is important is that the force and viscosity coefficient, how they are related to each other if we are having a ball moving inside a fluid. A small ball inside a fluid. Here is fluid and there is a small ball which is going here. Where is the viscosity involved? Answer is the ball is always wrapped by some liquid. That liquid and this liquid, that makes layer, this. And there is a viscosity force between these two layers. What does a viscous force do? It retards the motion. And this force, for that force, we have a relation. How much is that force? Anybody? Viscosity force, that is equal to 6. Yes. 6 pi eta and RV. Radius of this ball, V. This is coefficient of viscosity and this is the force. So force on a ball due to viscosity is given by this equation. This is a very important relation. This you must remember. And what is this known as? Yes, Stokes Law. This is sometimes also asked in dimensions. Prove that this is dimensionally correct. But anyway, you have no chance for this question. But this you must remember. In the Stokes Law, what is the force experienced by this is this. Based on this, there is one question. What is the difference between friction and viscosity? The answer is, in frictional formulas, you will not find velocity. What does friction do? Retards the motion. What does viscosity do? Retard the motion. That is doing in the solids, viscosity is doing in the fluids. But what is the difference? The friction is not affected by velocity. This is purely affected by velocity. So if a cycle is moving, its velocity is 10 and it becomes 20. There is hardly any difference in the kinetic friction. It will be same. But in case of viscosity, if the velocity goes from 10 to 20, the force will get double. Right? So this is the difference between the two. Okay, then we have now please understand here, when it is falling down, then due to mg, acceleration due to gravity, its velocity goes on increasing. If the velocity goes on increasing, what will happen to force? In which direction this force is acting? Opposing the velocity, that is upward, this way. This is force of viscosity, viscous force, and this is mg remains same whether it is here, here, here or here, right? But this force keeps on changing. Why? This is a accelerated motion. Velocity goes on increasing. So the viscous force goes on increasing. Increasing, increasing, increasing. At this point, it becomes equal to mg. When it becomes equal to mg, what will happen to the ball? It will stop? No? Yes? What will happen to the ball when the two forces become equal to each other and they cancel each other? Pardon? Yes. What stops is the force. And force is equal to mass into acceleration. So what stops? Acceleration. That means increase in the velocity stop. Velocity does not stop. Understand? So from here the velocity has become 2, 4, 6, 8, 10. Force has become equal. Now 10, 10, 10, 10, 10. Because the acceleration has become 0. So this velocity now stop increasing. Stop increasing. So we give it a name, terminal velocity. What is the name? Yes, because the increase has been terminated. Terminal velocity. That means after falling through certain length, the velocity is so much so that the viscous force and gravitational force become equal, and after that velocity do not increase anymore. This is a natural phenomenon, right? Terminal velocity. And how much is this terminal velocity? We have a formula for this, and that formula is velocity terminal. This is equal to, we can do it here by making an equation of the forces, and finally it will come to 2 upon 9. This will be r square rho minus sigma into g divided by eta. This is terminal velocity relation. So terminal velocity will increase with r. What is r? Radius. Radius of the ball. And double the effect. Means it's very effective. Smaller is the ball. Smaller is the ball. Smaller is terminal velocity. Okay? And larger is the ball. Larger is terminal. Means velocity will increase. If increase more, if the radius is large, then after it will become terminal. But if it is very small, yes, then it depends upon what? Density of the material of the ball, and this is what? Density of the air or the medium, the liquid, right? This is coefficient of viscosity G. These are constant. So with this there are questions. If the radius is small, the terminal velocity will be small. If the density is more, terminal velocity will be more. So you have to understand which are the things which decide it. Now, a raindrop which is falling from a height of 5 kilometer, 5,000 meter. It starts with a velocity. It has an acceleration g that is equal to 10. Now you tell me, when it reaches earth, what should be its velocity? V square is equal to u square plus 2 into a into s. How much it comes to? 1, 2, 3, 4, 5. One lakh meter per second. That is so a raindrop which is coming from 5 kilometer above cloud. Pardon? Oh, that is V square. So this will be Right. Okay, 10 kilometer per second. In 1 second, how much distance? 10 kilometer. It is like a bullet. So a drop which is falling from 5 kilometer above cloud, when it reaches ground, according to our equations, what should be its velocity? 10 kilometer per second. 10,000 meter per second. 10,000 meter, you understand? How much is our car which is going with velocity of 72 kilometer per second? Convert it 72, 20 meter per second. How much is the speed? 72 kilometer. You have seen how fast is the car. 72 kilometer per hour. This is 10 kilometer per second. How much it comes to in meter? 10,000. And how much is that car? 72 kilometer. 20 meter per second. This is 1,000 meter per second. Assume how fast it will be. So if that water drop is coming with such a high speed, you put your hand here, it will puncture it. Sure. It is so fast. Understand? And it follows from you. Why it is not there like that? Because the God has made, the nature has made safety for us by this phenomenon. Terminal velocity. The moment it comes down, there is a terminal velocity. There is a viscosity force, and with this viscosity force, the radius of the drop is very, very small. So terminal velocity is very small. It starts 0, 2, 4, 6, 8, terminal velocity has come. That's all. It is so small that 0 to 1, 2, terminal velocity has come. So now it falls 2, 2, 2, 2, 2 up to the earth. Such a slow one. But if the radius increase, yes. And if there are those, what do you call it? Ice? I don't know what do you call it. Whatever it is. It has more density and that's very powerful. Its velocity is very large. So we must be careful. Anyway, the raindrops do not have high velocity because of viscosity. Otherwise, it will be very dangerous. And that velocity is very, very small. It is so small that even the flowing air there will take it away with it. Right? It is so small that a very small air current, negligible air current, does not allow it to fall. What do we call it? Mist. Mist are, after all, water particles. Why don't they fall? Because their terminal velocity is 0.001. Even if they fall by 1 meter, it takes around 1 hour. So all 1 hour we see water is there. And what we call it? Mist. Because it is falling with terminal velocity. Its radius is so small that terminal velocity is very, very small. Understand? So these are the effect of terminal velocity. Now, after this terminal velocity, we have another thing here, that is Reynolds number. The other thing which is asked is Reynolds number. What is Reynolds number? Reynolds number is a calculation based on viscosity which is related to this was terminal velocity, that is related to critical velocity. What happens when flow of a liquid cross critical velocity? Answer, it becomes turbulent. And when it becomes turbulent, what is the effect? The pipe through which it is moving, the walls will have lot of pressure and they will collapse. For that purpose, because all over the world we are carrying fluid in the pipes. The petrol we are using here comes in the pipe from Arabian countries. The petrol we are having in Assam is coming through the pipes. Everywhere there is a flow of fluid in the pipes, and our drinking water comes through pipe. So that is everywhere. So it is very, very important that the flow should not be turbulent. It should always remain, yes, streamlined. So for that, engineers do a calculation. We have done calculation based on that streamline and the forces and this, that. And after that, we are doing a calculation which is based on the density of liquid, velocity, and diameter of the pipe. So density of liquid, velocity of liquid, and diameter of pipe, and this is to be divided by coefficient of viscosity. This will give us a number. This will give a number. We calculate it. When we calculate it, this number comes, it has certain value, and then we make a measurement. If Reynolds number is less than 1000, then our flow is streamlined. If Reynolds number is more than 2000, then this is turbulent. Sure. So it is always kept below 1000 or approximately 1000, so that we use the optimum quantity of the flow, but at the same time the pipe should not be damaged, because there is always a pressure for more production, for more transmission. So there is a pressure from the top, increase the velocity so that we can get more fluid, but when we increase there is always a risk for the maintenance people, so they don't. So there is always a fight, and this is the deciding factor, that Reynolds number cannot be more than 1000. And from here there is a mixture, some layer streamlined, some layer turbulent, and after 2000 it is totally turbulent. So that is a risky one. Okay, so this is Reynolds number, where it is used to find whether a flow is streamlined or turbulent. Okay. So Reynolds number, what this indicate is inertial force divided by viscous force. But this is of not much value to you. For engineering calculations we do that. Only this thing is good enough, and this value, this you must remember. Okay, so this is all about viscosity. Now, one small thing is left, we will do it now, and that is surface tension. Surface tension. Surface tension is again property of fluid based on intermolecular forces. Whatever we are studying is based on intermolecular forces. So the molecules of fluid, they attract each other and there is a force between them. Once the distance between them increase, the solid converts into liquid. So in liquid already distance is quite large. Okay. Now, there are molecules here. We draw a line anywhere. Let us suppose we draw a line here. Then there are certain molecules on this side and there are molecules on this side. These molecules are attracting each other. Yes, this way. They are applying force on each other. We add up all the force. Theoretically, we add up all the force and we count this length L. And sum of all the forces is F. Then the force per unit length. L length has how much force? F. One length will have how much force? So force per unit length is known as surface tension. So the basic formula for surface tension is this: force per unit length, and this force is in what direction? Inside the liquid or along the surface?
Along the surface.
Along the surface. That is tangential to the surface. Right? So, please remember, this is tangential. Now, what should be its unit? Newton per
meter.
Yes, Newton per meter. And what should be its dimensions? Mt minus 1. L is cancelled. MLT minus 2 is the force, no? So 1 L is cancelled. So this is Mt minus 1, that is surface tension. Okay. Next, surface energy. Whenever a surface is formed, what happens? You see, there is a force of attraction and there is a distance. And we have learned that whenever there is a force of attraction and there is a distance, the system has got energy. Somebody has done this energy. Somebody has worked on it. That is why the surface is created. Otherwise, what should have happened? Because of the force of attraction, all should have made a drop. So this drop, let us take one particle here, one here, one here, one here, one here, and this has become a surface. So when we convert a drop into a surface, what we are doing? Pushing all the particles away, we are doing certain work. That work converts into potential energy of the surface. Right? Potential energy of the surface. So every surface has got potential energy. How much is that potential energy? That we can calculate, that we have calculated. So after the calculation, what we get is surface energy is equal to area multiplied by surface tension. You see, you can see it very well. Surface tension is what? Force upon length. What is area? Length into length? One length is cancelled. So what it will be? Force into length. And force into length is what? Work done. Right? So please remember this as it is. That is good. You don't have to prove it in the exam. What you will remember? In any surface, the energy is equal to area multiplied by surface tension. Okay. Now if area is equal to 1, then surface energy is equal to surface tension. But energy can never be equal to force. So what do we say? Energy is numerically equal to the force which is required to create it in the area of unit. Again, we can rephrase it, we can make it correct, that surface tension multiplied by unit area is equal to energy. So this formula you must remember. Now this is the force. One very small thing, what is the effect of temperature on surface tension? So please remember, when temperature increase, the vibration increase, the surface tension become less. If there is a force here 10 Newton and there is a suddenly, because of temperature increase, it will start vibrating. So there is a disturbance to the 2 and this 10 become 8. Where the 2 has gone? Because of the vibration. So if the temperature increase, surface tension decrease. This is something which is sometimes asked in the examinations. Small things. Okay, then in this next thing, surface tension, what does it do? What is the general tendency of the surface tension? Please remember, this is the most important thing. What is the general tendency of surface tension? Yes, it is always try to reduce the area. It is always trying to reduce the area. It works as a stretched rubber string. What does it do? Any stretched rubber string always try to reduce its area. Right? So that is the tendency. Please remember it. Okay. So if it is trying to decrease the area, if area is decreased, what will be decreased? And this is a general tendency of any system. Any system in this universe try to remain in a condition where the energy contents are minimum. Right? So it is doing its action. All the actions in this universe are related that system energy become less. So they move like that. Okay. Now with this, if we have a drop, if we have many particles, this, all these particles, we put them in the space. We just bounce it, 100 Pascal, and we ask them, you make a shape according to yourself. Combine and make a shape. Whether you want to be a cube, cuboid, cone, whatever you want to, you make. What is the criteria? They will ask in which the expenses are minimum. Right? In which the energy consumption is minimum. And minimum energy consumption means minimum area. So geometrically we know for any content, the minimum area is with the sphere. With maximum volume, minimum area, which shape is that? Sphere. So all the fluid would like to take a shape of sphere. Why? Yes, this is a very important question, that any fluid which is thrown free, which shape will it choose? It will choose sphere, because for any given volume, sphere has the minimum area, therefore it needs minimum energy. That's why it becomes surface. Okay. Now it has become a sphere. When it has become a sphere, then on the top there are so many particles of the fluid. All these particles want to go inside. There is no space inside. Now if I have this here, what is the distance between the fingers? No distance. If I put it here, now there is a distance and there is a force. I have to do the work. But if the liquid is so much, it cannot be accommodated in, it can be accommodated in this. So there are certain particles which has to be here, maintaining some distance. So what do? They want to attract each other. They are like a stretched rubber. They are forcing each other and there is a pressure. There is a pressure. So in a water drop, in a liquid drop, the layer all around it is trying to squeeze. Why trying to squeeze? It is trying to decrease its surface area. It is trying to decrease. So what is the effect? If it is pressing it, the pressure inside increase. The pressure inside increase. Therefore, compared to outside the drop, inside the drop, there is excess pressure. There is excess pressure because of surface tension. How much is this excess pressure here? Drop. Excess pressure is equal to, this is 2s upon r, 2 or 4, yes, 2s upon r. This is the radius. This is for drop. Okay. If we have a bubble, you see in the drop, how many free surfaces were there? One, all around it. But in a bubble, this is one free surface and there is a second free surface. Both surfaces are trying to contract, so the force will be doubled. So the pressure inside a drop and inside a bubble. 4S upon R. The pressure inside drop, pressure inside bubble. Right. Now because of this surface tension, we have studied in the fluid, if we put a capillary, there is a rise of this liquid in it, H. This H has a relation. What is that formula? H is equal to surface tension divided by R into rho into G. What is S? Surface tension of the fluid. What is R? Radius of the capillary tube. What is rho? Density of the fluid. G you know. What is theta? Theta is angle of contact. If I magnify this thing, then this is our pipe. In the pipe, the liquid, yes, it makes a meniscus this way. And this angle within the liquid, this angle is known as angle of contact. Angle of contact, that is here theta. This angle of contact is acute for some and it is obtuse for some. When it is acute, what do we say? Pardon? We say the liquid wets the solid. Liquid wets the solid. It will spread over the solid like water on the glass. If it is obtuse, then we say they don't like each other and it does not wet the glass. That is mercury on the glass. So mercury on the glass, see here, this is glass and this is one, and this is glass and this is one. Here the angle is this. Here the angle is this. Angle has to be in the liquid. Angle has to be in the liquid. This is obtuse. This is, yes, acute. Here we say it is trying to spread. It is trying to wet the surface. And this do not wet. This is example, water on glass. Wetting, non-wetting. So here it is. In this case, the water will rise. But if in place of water we have mercury, then it will dip down. If this is mercury and we put a capillary, the mercury will go here. Yes, it will go down. Hg. And this is water. The water goes up because it wets. So there is a set. It wets the glass. Angle is acute. It will rise in the capillary and it wets it. In this case, does not wet. Go lower in the capillary. Meniscus is convex and the angle is obtuse. All these four qualities you must remember. Angle, whether it is rise or whether it dips, whether it wets or not. Right? So these are the properties of it. And yes, it is done. So this was all about surface tension, its properties, and we have to make numericals based on all these properties we have studied and little bit of formulas. So if you remember all the formulas, then you have remembered the properties, because every formula represents a property, right? You will always see this quantity is directly proportionate and which quantity are inversely proportionate. Each formula gives you one relation, one definition. So even if you remember all, at that time if you know which are the quantities, then you have done the lesson. Okay? So based on this we will do certain numericals tomorrow, and all other chapters have been done. Whatever is your doubt, you can bring it tomorrow, we will do that. Otherwise, class 11 portion is complete. Thank you.